I'm Fleshed Out Thoughts, and I love fleshing out thoughts for extended periods of time. I'm building a full-stack e-commerce platform for digital products and software services with Next.js and Supabase. This series is about the architectural decisions behind the platform, what I built, why I built it that way, and what I do differently. Today we're going to be getting into observability for my Next.js e-commerce platform, logs, metrics, and what I'll add next. Without further ado, let's continue. Observability is the ability to understand what your system is doing from its external outputs without modifying or redeploying. Here's the operational test I use. If a user reports that their order confirmation never arrived, can I figure out what happened using only the logs and data my platform already emits? Can I reconstruct the full timeline, order created, payment attempted, Stripe response, email dispatched, or failed without SSHing into a server, adding a log statement, or deploying new code? If yes, I have observability. If no, I have logs that require interpretation under pressure, which is a different thing. Right now, the answer is yes, because I structure my logs deliberately. I have a small logging utility called safeLog that produces structured JSON output. It automatically hashes emails, masks IP address, and ensures every log line has a consistent shape. I use domain identifiers such as order IDs, cart IDs, session IDs, and I use them to correlate log lines without a formal request scoped correlation ID. This video is about my current observability setup, how safeLog works, how I think about SLOs, and what I'll add and when my platform grows. What Vercel and Supabase give me for free. This is a rung 0 on the observability ladder. HTTP domain structure, not business domain structure. What's included in this? Well, Vercel request logs give me HTTP methods, path, status code, duration, and timestamp for every request. All console output from my server actions is captured and searchable by the range. Supabase query logs show every database query, its duration, whether it succeeded, and how many rows it affected. And unhandled exceptions are caught and surfaced in the dashboard via error boundaries. For a solo developer debugging their own code, this is surprisingly capable. I can filter by time range, search for specific error messages, and correlate requests by timestamp. The gap is on the right side of the slide. Vercel knows that a post to API checkout returned 200 in 850 milliseconds. It does not know how the checkout was for the order ABC123, that a coupon was applied for $15, that the Stripe call took 320 of those 850 milliseconds, or that an email was queued as a result. That is business context. The fields I care about, safeLog adds it. And the decision, Vercel provides HTTP domain structure. safeLog adds business domain structure. Both are necessary. safeLog, structured logging without dependency. safeLog is about 50 lines of code. It wraps console.log and automatically produces structured JSON. It accepts an event name and an optional data object, and its output a JSON line with timestamp, level, event, and whatever context fields you pass in. 3 automatic protections happen on every call. The first protection is email to salted SHA256 hash. alice@example.com becomes hashed. The raw email never appears in logs. The salt matters. Without it, SHA256 of any known email address is deterministic and reversible by anyone with the logs and a dictionary. With a salt stored separately from the logs, the hash is specific to your installation and cannot be reversed without it. This is the kind of defense that survives an attacker who's read access to your log storage. The second protection, IP to first 2 octets. So the address 192.168.142 becomes 192.168.x.x. Enough for geo-region analysis, not enough to identify an individual. And it's not maskable by a simple grep. The x.x notation makes clear masking was deliberate. And the third protection, user agent to browser family. The full user agent string is reduced to the browser name only. Chrome, Safari, Firefox. The version details are stripped. It's useful for browser distribution analysis, not useful for fingerprint. Privacy protections that are automatic are the only kind that work at scale. SafeLog means you never have to remember to redact PII. The function does it every time for every caller. I don't need Pinot or Winston yet. When I need log levels, transports, or sampling, I can swap the implementation behind the same function signature without changing any of the call sites. The log structure, action boundaries, not function calls. The slide shows the same business event, a payment declining during checkout, logged 2 ways. On the left, an unstructured log, 3 separate lines across 2 seconds. Checkout failed for user, Stripe error, card declined, email queued. 4 problems listed, which order, which user, grep, and hope to correlate. A machine can't parse it reliably. On the right, the same event as structured JSON. On log line, timestamp, level, event, payment declined, order ID, user ID, amount pence or cents, the raw PII. The user ID, not email, and duration millisecond shows where the time went. The design principle in the lower left. Log at action boundaries, not function boundaries. A validate coupon might be called 3 times in a checkout flow, but the checkout is one business action. Logging each internal function call produces noise where the signal is buried. Logging the checkout result, that includes which validation step failed, if any, produces 1 or 2 lines that tell the complete business story. The field conventions on the lower left right. Timestamp is ISO 8601 always. Level is debug, info, warn, or error. Event is dot separated, order.created, payment.declined. The IDs use the ID suffix, and duration milliseconds is on or on every action. The decision, log at action boundaries. The order of events in the log should reflect business events, not the call stack. Correlation by domain and identifier. I don't have a formal correlation ID that propagates through every function call. What I have is domain-specific identifiers, order IDs, cart IDs, session IDs that serve the same purpose for a single service platform. The slide shows a 4-event timeline for one payment failure. Every event carries an order ID and the order. Here we go. Yep. At the timestamp 14/23/01/412, right? Order.created, the cart locked, UUID assigned, user ID, and amount pence in the field. And you'll have to bear with me for the example. This is just for the slide. We're using cents because we don't have pence here in America. Not that kind of pence. Anyways, at 14/23/01/831, payment attempted. The Stripe call initiated. Provider and item potency key, those are logged. Okay, the following line. At 14/23/02.149, Stripe.response, the decline is returned. Results decline. The code is insufficient funds. The duration is for 318 milliseconds. At 14/23/02.163, payment.declined.handle, the error returned to the client as retriable false and the customer notified is true. Every log line that touches this order includes the order ID. If a user files a support ticket about order ABC123, I search the logs for that ID and see the complete lifecycle as sequence. This is sufficient for a single service. The failure mode worth understanding. A domain identifier links all logs about the same order, but it doesn't link all logs from the same requests across multiple services. When I add a background workers or separate services, I'll add a request scoped correlation ID. The upgrade is straightforward. The foundation, consistent field names, structured logs, business event identifiers. These are already in place. SLOs, making reliability decisions objective. The dashboard on the slide shows 3 live metrics. Availability at 99.94% against the 99.9 target. P99 latency at 312 milliseconds against a 300 millisecond target, an error rate of 0.06% against a 0.1% target. Below that, error budget remaining, the availability at 78%, latency at 41%, error rate at 94%, and a table of recent incidents with their budget impact. Here are 3 vocabulary terms that need to be very precise, right? The SLI, the service level indicator, is the thing you actually measure. For checkout, the proportion of checkout requests that complete successfully. The SLO, service level objective. This is your internal target for that SLI. The SLI should be a 99.5 over a 30-day rolling window. And thirdly, the error budget. This is the time remaining before you breach the SLO. At 99.5%, my error budget is about 3.6 hours per month. A single bad deployment that takes 30 minutes to roll back consumes 14% of it. At 99.9%, the budget is 44 minutes. One bad rollback and you're done for the month. The error budget makes reliability decisions objective. Budget the remaining. Ship features. Budget exhausted. Stop shipping. Focus on reliability. It replaces, is this risky enough to worry about, with a number. I don't have this dashboard yet, but defining the SLO now means I know exactly what to build. The 3 observability pillars. 3 signal types work together in a mature observability setup. Each answers a different question. Each has a status badge showing where I am today. First being metrics. Numeric measurements aggregated over time, request rate, error rate, P95 latency. They answer, is something wrong? An error rate spike at 2 a.m. triggers an alert. Status, not yet. My metrics are implicit via Vercel. I can inspect them, but I can't alert on them. The logs. They're structured record of discrete business events. They answer, what exactly happened? The alert fires. I open the logs and I see which specific request failed and with what errors. Status, I have now via safeLog. Traces. These are the records of a request journey across services. They answer, where in the chain is the bottleneck? The logs tell you a checkout failed. The trace tells you the Stripe call at step 3 took 4.2 seconds. Status, not quite there yet. I have a single service, so traces aren't needed yet. The connection between them matters as much as having all 3. When a metric alert fires, you want to click from the metric directly to a log line from the exact spike, not run a separate time range search. From the log line, you want to jump to the trace for that specific request. Without that linking 3 separate investigations with it, one connected one. The foundation, structured log with consistent field names. This is what metrics are and traces build on. Logs first. The foundation, structured log with consistent field names, is what metrics and traces are built on. Log discipline, signal versus noise versus risk. Log discipline prevents 2 failure modes, missing signals and burying signals in noise. The subtitle of this slide says it directly. A log containing PII is a data store subject to write to erasure. Don't put PII in logs and you don't have to erase it. Log level should mean something. Debug. The internal steps, right? Every database query, intermediate values, you enable only while actively debugging, never in production, okay? The information, the business events, order created, payment authorized, email dispatched. 1 line per significant action. The warning, recoverable errors. A coupon exhausted but the flow continued. Retry succeeded on the 2nd attempt. Also, failures requiring attention. Payment declined after retries. State machine rejected a transition. Most developers set everything to info and then can't find the signal. Warn is the level that tells you this happened but was handled. Error is the level that should trigger investigation. If those 2 are drowned in info noise, you've broken your own signal. Things we should probably never log, right? We don't log raw email addresses. Use user ID or the safeLog hash. The Stripe secret keys log last 4 digits of card only. Auth tokens and JWTs use session ID or user ID. Full shipping addresses, country and postal prefix only. Payment card data, nothing. PCI prohibits it. Raw IP addresses, safeLog masks to x.x automatically. The GDPR insight. If a user requests erasure and their email address is in 90 days of log files, you have a compliance problem. If you don't put PII in your logs, you don't have to erase it from your logs. The logs are fully useful without raw PII. It's a design decision that eliminates a compliance obligation. My Observability Roadmap. The roadmap follows the question sequence. Is something wrong? And what exactly happened? Where is the chain? The first step, explicit metrics and alerting. Near term, but for the first paying customer, Vercel Analytics or a lightweight metrics endpoint tracking checkout success rate, P95 latency, and error rate over time. The key shift is alerting on SLO burn rate, not just error rate above X%, but consuming error. The key shift is alerting on SLO burn rate, not just error rate above X%, but consuming error budget faster than I can sustain over the remaining window. That's alerting on symptoms, not causes. From implicit metrics I inspect to explicit metrics I alert on. Step 2. Request scope correlation IDs. Triggered by the first background job or second service, a UUID generated at request ingress, threaded through every function call, included in every log line. This replaces domain identifier correlation for cross-service requests. This is the foundation for distributed tracing. From order ID correlates logs to request ID correlates services. Step 3. Distributed tracing with open telemetry. Triggered by multiple services or background workers, open telemetry instrumentation, Jaeger or a cloud tracing backend. Follow a request across service boundaries. Identify bottlenecks that logs can't surface. Which span in the chain is slow? From correlate by domain ID to correlate by trace and span. The decision, observability infrastructure grows with platform complexity, not ahead of it. Don't add Prometheus until you have metrics to query over arbitrary time ranges. Don't add tracing until you have multiple services. Summary: observability is a design activity, not an afterthought. The cost of retrofitting it is very high. Finding every console.log across your code base, re-instrumenting it with consistent field names and waiting for enough traffic to validate the new logs are complete. Also, while flying blind during exactly the period when you need it most. Building it in from day one is cheap. Building it later is expensive and happens at the worst time. So the 5 key takeaways are: structured logs from day one. safeLog gives me structured JSON output, automatic PII masking, and consistent field names without external dependencies. I have built it in, made it automatic, it made it the default. Log at action boundaries, not function boundaries. Coupon validate start called 3 times is noise. Checkout decline with context is signal. The log reads as business events timeline flow, not a call stack. Domain identifiers for correlation. Order ID links every log line about that order. Upgrade to request scoped IDs when you add multiple services. The structured foundation is already in place. Define SLOs before you need them. SLI is what you measure. SLO is your internal target. Error budget makes reliability decisions objective. You don't need the dashboard to have the target. The 3 pillars, 3 different questions, right? Metrics presents, is something wrong? The logs present, what has happened? And the traces present, where in the chain? Logs first, metrics and alerting at paying customers, traces at multiple services. For a client, the platform emits structured logs from every significant business operation. PII is automatically masked. Logs are shareable without risk. Domain identifiers enable full lifecycle reconstruction for any order without additional tooling or redeployment. So to wrap this up, I'm fleshed out thoughts. I'm building a full stack e-commerce platform for digital products and software services with Next.js and Supabase. If you're thinking through observability for your own platform, structured logging, SLO definitions, or when to add Prometheus, reach out. I'm open to freelance projects and consulting. The full post is linked in the description. It has a complete safeLog implementation to the log field reference, the SLO framework with error budget calculations, and the alerting guide. This video completes the e-commerce platform architecture series. 15 posts across API contracts, authentication, authorization, cache strategy, cap theorem, rate limiting, proxies, asynchronous system design, concurrency, database design, estimation and capacity, front-end architecture, data management, database scaling, and observability. From here, a separate series on building a deterministic chaos engineering lab in Go with fault injection, Linux internals, and system programming. If that sounds interesting, please subscribe and I'll see you there.